So one really good option for renewable energy that doesn't cause a whole lot of problems is solar power. Now, I say good option because we live in San Diego and we have a lot of sun in San Diego. So solar power is not going to necessarily be the best option everywhere because there's definitely places that don't get a whole lot of sunlight. But in areas like Southern California, where we have a lot of sunlight and we don't get a lot of rain and we don't, at least in a large part of Southern California, we don't have snow problems or things like that, solar power is a good option. So when we look at solar power, there's not a lot of people that have solar power. So like less than 1% we get from solar energy. Now, this is a few years old though. Like I actually probably should look up the more current statistic because more solar panels have definitely gone in. Like we have solar panels on our house, and in fact, since the last time I taught this class, we've doubled the number of solar panels on our house. But part of that's because of COVID. So my husband works from home now. He's out in the field a lot, but his primary working is from home. I still teach online classes, so I work from home a few days a week. So we definitely were using more power at home, so we got more solar panels. So we do need to start adding, more solar in areas that can have it. Even for camping, we have a camping trailer and I have a portable solar panel that we take with us. It doesn't provide all of our power. Like, it doesn't provide enough power to run our air conditioning. Yes, I have an air conditioning in my camping trailer. But it does provide a decent amount of power for some of the lower stuff. I could get more solar panels or a bigger one, but I just have a small portable one, so it doesn't provide a ton of power. But it still provides some. And so what's really cool is that there's a lot of places that aren't on an electrical grid, and because you can have these portable solar panels, there are places that you can take small solar panels to, and now those places have electricity where they didn't have any because it's not in an area where they're able to run power lines or create a power grid yet. So this is really cool that solar can take power to people in remote areas as well. Okay, and so we get these photovoltaic cells. So there's some electrodes there. There's a surface on there. So one thing that you do have to be careful of is because you've got this surface with this coating is they do have to be cleaned. In fact, we probably need to get up on the roof and hose ours down because we do that maybe twice a year to make sure, because if too much gunk is on them, then you're going to impede the ability of light to hit the photovoltaic cells and actually produce electricity. And so you get these N-type and P-type semiconductors, and so these are doped with different things, and so those generate electricity. And so when we look at those photovoltaic cells, what happens is certain energies of light can free electrons between silicon atoms in the solid, and then that electron moves around, making the silicon an electrical conductor. And so we get a better increase in efficiency by doping with atoms that have either excess electrons or fewer electrons. And so that's where we get this p-type doping and this n-type doping. And so we get a junction between those where the electrons move through. Okay, and so we get these excited. So because in order to generate electricity, we have to have mobile charge. And so if we can get electrons to move around, we have mobile charge. This is why metals are such good conductors, is they have freely moving electrons, so there's mobile charge. Okay, and so we get these electrons moving through there. We have some efficiency, so we've got photons. So what happens is you have to have enough energy. In order to get an electron free, there's this basically there's a threshold energy, and so if you have a photon that's of insufficient energy, and so the photon is this packet of energy or this light that hits it, and so if you have insufficient energy, you're not going to knock the electron loose, and so you have to make sure you're getting enough energy. And so we can actually calculate that threshold frequency, and so we know the amount of energy that has to be hitting it in order to get the electron to bounce free. We don't have the best efficiency with these. There's a 21% efficiency as of 2015. So that's one of the things, is that there is technology constantly developing. So if you have really old solar panels, they're not going to be as efficient as newer solar panels because the technology is not as good. We get better efficiency if we have multi-layer cells. These are a lot more expensive though, because they layer all of the different solar cells together. And so you're, instead of just one solar cell, you've got a ton of them, which is why they get more expensive. But even then, they don't increase the efficiency. I mean, they double it, a little more than double it, but it still doesn't quite even get to 50%. So still an area where we have a lot of work to be done in order to increase the efficiency. And then there's also the issue of, like, let's say I wanted to disconnect from the grid. It's nighttime right now. I don't have batteries. That's one of the problems, is right now we don't have the best battery technology to take what we generate during the day, which is more than we're using, and store it for nighttime usage. The batteries are very expensive and their efficiency isn't the best. And as you transfer from one thing to the next, you actually do lose some. Some of that electricity is converted into heat energy, and so you don't get 100% efficiency when you're storing it either. And so that's another area where we're still working on the technology in order to make it more viable for long-term usage, and being able to disconnect from like SDG&E's grid. Is we need better ability to store into batteries, and we need affordable batteries. And we also need batteries that will last a long time too. That is another issue, is that batteries aren't perfect. They do, even rechargeable ones, they wear out after a while. There's only so many times you can charge up and discharge and charge and discharge a battery before it's no longer efficient to keep doing that either. So they're in the works. Solar energy in sunny areas, very, very good source of energy. But in order for it to be a viable source of energy to the point that we can disconnect from some of these other grids, we still have more work that needs to be done with that. So there's always more work to be done in science.